Good evening, everybody. My name is Farhan Mazhar, and today we are working on the course book of the Pure Maths 1. We are working on the exercise 5G, and this is our second episode on this exercise. The topic of the chapter is trigonometry, and the topic of this exercise is trigonometric identities. We are working on the question number 4, and the question number 4 and its a part. Let me show you the question. The question number 4 a part, we have to prove each of these identities. The a part is cos square x minus sin square x is equals to 2 cos square x minus 1. So what I will do, I will take the the second the left hand side, and that is 2 cos square x minus sin square x. And because in the right hand side I want the answer only in the cos x terms, so what I will do, the sin square x will be substituted. You see this sin square x, I will substitute that with the 1 minus cos square x. You see I have written it in the red color. So this sin square x can be substituted with 1 minus cos square x. So due to this minus, when you open this bracket, the signs will change. So you will have cos square x minus 1 plus cos square x plus cos square x. That will give you 2 cos square x and minus 1. So this is equals to your right hand side, and this is how you will do the question number 4 and its a part. I hope you understand. So my dear students, now we will do the question number 4 and its B part. Let me show you that question. Question number 4, B part, cos square x minus sin square x is equals to 1 minus 2 sin square x. So very simple, uh, I will take the left hand side. I will consider the left hand side. The left hand side says cos square of the x minus sine square of the x. In the right hand side, we have the expression only in terms of the sine square x. So I need to get rid of this cos square x. So in the place of the cos square x, I can substitute 1 minus sine square x, and then you have minus sine square x, and this will become 1 minus sine square x minus sine and square x. So this will become 1 minus 2 sine square of the x, which is equal to the right hand side. So this is, so you see on the right hand side the same expression. So this is how you will prove. This is the question number 4 and its B part. This is how this question is done. I hope you understand. We are working on the paper 1 syllabus content of the Cambridge International AS A Levels Mathematics 9709. We are working on the exercise 5G. This is our second episode on this exercise. This is question number 4 and its B part. The solution is right in front of you. So my dear students, now we will work on the question number 4 and its C part. Let me show you the question. The question number 4, it's a C part. Prove each of these identities. Tan square x minus sin square x is equals to tan square x sin square x. We have to prove that. Okay, so we will consider the left hand side. Okay, so let me do that. So you will have tan square x minus sine square x. Okay, so what we can do, I want to show this, both the things are there. Okay, so you know the tan can be written as this is sine x by the cos x, and it's square and square because tan square. So we will have minus sine square x. So what here we have by 1. So I will take the LCM. So the LCM will be cos square x. So here you will have sine square x minus sine square x, and this will come upstairs. So it will become cos square x. Okay. So you will have, you can take sine square x common from the top. Okay. In the bracket, you will have 1 minus cos square x. In the denominator, you will have cos square x. You know the sine square x by cos square x, that will be equal to the tan square x bracket 1 minus cos square x, that is equal to the sine square x. Okay, so you will have at then tan square x into the sine square x, and which is equals to the right hand side. So this is how this is done. I hope you understand this, and this is how you will prove that the left hand side is equal to the right hand side. So this is how we are done with the question number 4 and its C part. If you want more time with that question, you can pause the video. So my dear students, now we are going to work on the question number 4 and its D part. The statement is showing up in front of you. Cos raised to power 4x plus sine square x is equal to sine raised to power 4x and plus cos square x. So we have to prove. Okay, so what I will do, I will consider its left hand side. So on the left hand side, you can see what we have here on left, cos raised to power 4x plus sine square x. So I will consider the left hand side. So cos raised to power 4 and cos x raised to power 4. So I can write it cos square of x is and no, cos x square and its square plus sine square x. In the place of the cos square x, I can write 1 minus sine square x, and you have whole square on it plus sine square x. So now I will take the square of this, like a minus b whole square is equals to a square minus 2ab plus b square. So when I open this whole square, this will become 1. 1 square is 1 minus 2 into 1 into sine square x. So it will be minus 2 sine square x plus sine. When you take the square of this thing, this will become sine x raised to power 4 plus this sine square x. Okay. So just write, because I want this in the right hand side, so I will bring it here. Then you have plus 1, then minus 2 sine square x plus sine square x. You are left with the minus sine square x. Okay, this will come as it is because I want this on the right hand side. 1 minus sine square x, in the place of 1 minus sine square x from the first identity, I can write cos square x. Okay, 1 minus sine square x is equals to the cos square x, and so this is your right hand side, you can see. So easy peasy. Okay, so this is how you will prove the question number 4 and its D part. The question number 4 is D part. I hope you understand this. So my dear students, now we are going to work on the question number 5 and its A part. The question is showing up on your screen. We have to prove each of these identities. Cos square x minus sine square x divided by the cos x minus sine x is equals to cos x plus sine x. So very simple. What we will do, we will consider its left hand side. So consider the left hand side, and that is cos square of the x minus sine square of the x divided by the cos of the x minus sine of the x. Okay, so this is like a square minus b square, that is equals to a plus b, a minus b, the difference of the two perfect squares. So I can also write this like cos of the x plus sine of the x in one bracket, and in the other bracket we will have cos of the x minus sine of the x and divided by cos of the x minus sine of the x. And you see this cancels, so you are left with the cos x plus the sine of the x, and this is equals to your right hand side. So this is how you do the question number 5 and its A part. I hope you understand. Question number 5, its A part. So my dear students, now we are going to work on the question number 5 and its B part. Question number 5 and its B part is showing up on your screen. Sine raised to power 4x minus cos 4x cos x raised to power 4 is equals to 2 sine square x minus 1. So we have to prove this. Okay, so what we will do, we will consider the left hand side. So you will have sine 4x minus cos 4, and the 4 means the power is 4. Okay, So I can write it like this: cos square x square minus cos square x square. So negative between two perfect squares, so you can write it like this: sine square x plus cos square x and sine square x minus cos square x. Okay, so sine square x plus cos square x, that is 1, and this is sine square x minus cos square x. So 1 will multiply, that makes no difference. Okay, so you will have sine square x minus, in the place of the cos square x, because I want the answer only in the terms of the sine, so the cos square x can be substituted. You know, the cos square x is equals to 1 minus sine square x. Cos square x is equals to 1 minus sine square x. So now this will become sine square x minus 1 plus sine square x. Sine square x plus sine square x, that will become 2 sine square x minus 1, which is equals to the right hand side. So this is how this is done. So my dear students, this is question number 5 and it's B part of the exercise 5G. This is our second episode on this exercise. The topic of the exercise is trigonometric identities. We are working on the course book of the Pure Maths 1. My name is Farhan Masar. So I hope you understand question number 5. It's B part. Question number 5. It's C part. Cos x raised to power 4 minus sin x raised to power 4, and the whole thing divided by cos x raised to power 2, and we have 1 minus 10 square x. Okay, so we have to prove the right hand side and the left hand side, they both are equal. So what I will do, I will consider the left hand side. So let's consider the left hand side. The left hand side. So you will have cos raised to power 4x minus sine raised to power 4x divided by the cos square of x. Okay, so you can write this as cos square x raised to power square minus sine square x raised to power square and divided by the cos square of the x. Okay, so square x. Okay, square of the x ni. So this is two perfect squares, you have a negative between them, so you can write them like cos square x plus sine square x in one bracket. This is a square minus b square is equals to a plus b, a minus b. Okay, so cos square of the x minus sine square of the x divided by the cos square x. Okay, so cos square x plus sine square x, that is 1, and you will have here cos square x minus sine square of the x divided by the cos square x. Because the answer is in the form of tan, so upstairs you need only, you need so you no need to write 1. So we need to replace this cos square. Upstairs I only want sine. So okay, so we can separate. No, instead of doing this, you can separate this denominator under them. So you will have cos square x. So cos square x by cos square x, that is 1 minus sine square x by cos square x, that is tan square of the x, which is equals to the right hand side. So my dear student, this is how we will do the question number 5 and its C part. This is how you will prove the left hand side and the right hand side, they both are equals to each other. So this was your question number 5 and its C part and its solution. So now we are on the question number 5 and its D part. Let me show you the question. The question number 5 and its D part. So cos x divided by, in the denominator we have tan x bracket 1 minus sin x bracket close. We have to prove that this is equals to 1 plus sin x. Okay. So as usual, what we will do, we will consider the your left hand side. Okay, so we are going to take the left hand side. So I will consider the left hand side. So you will have cos of the x divided by the tan x bracket 1 minus sine of x. So in the place of this tan x, what you can do, you can substitute it as sine of x by the cos of the x into 1 minus sine of the x. Okay, so when this fraction will come upstairs, so you will have cos x into the cos of the x divided by the sine of the x into 1 minus sine x. Okay, so I bring it upstairs, this will come upstairs, this will remain downstairs. This becomes your cos square of the x divided by the sine of the x into 1 minus sine x. So in the place of the cos square x, I can write 1 minus sine square x divided by the sine of the x into 1 minus sine of the x. Okay, so 1 minus sine square x, 1 is a perfect square. Okay, and sine square x is also a perfect square. So what I can do, I can write it like 1 plus sine x into 1 minus sine x. Okay, and here you will have sine x, and here you will have 1 minus sine x. So now this bracket will be gone, cancel with each other. So sine x divided by the sine x. Okay, so this will now separate this denominator, give them under each numerator, the term in the numerator, I mean. So you will have this. So this will become 1. Okay, so I can write it first. Okay, 1 divided by the sine of the x plus 1. So I can write it like 1 plus 1 by sine of the x, and that is your right hand side. So this is how you will do the question number 1. Sorry, question number 5, and it's D part, a little longer question. So I hope you understand how we have proved that the left hand side is equals to the right hand side. It's not very difficult. We are working on the exercise 5G. This is our second episode on this exercise. We are working on the solution of the Pure Maths 1 course book. And the topic of this exercise is trigonometric identities. My name is Farhan Mazhar and I'm from Sargodha, Pakistan. So my dear students, now we are working on the question number 5. It's E part. Let me show you the question from the book. Question number 5, and it's E part. So it says sin x minus cos x divided by sin x plus cos x. We have to prove that this is equals to tan x minus 1 divided by the tan x plus 1. So let's see how we can do that. Question number 5, E part. So we will consider what we will do. We will consider I can consider the left hand side. So let's consider the left hand side. That says sine of the x minus cos of the x divided by sine of the x plus cos of the x. Okay, so you see a very unusual thing I will do. I will divide the numerator with the tan x, sorry, with the cos x, sorry, I said tan x, and same thing I will do in the numerator. So all the terms in the numerator I am dividing with the cos x. Okay, this is what I can do. So I divided all the terms in the numerator with the cos x. I divided with all the terms in the denominator with the cos x. So see what the magic is. Sin x by cos x, that is tan x. Cos x cancel. This is 1. Sin x by cos x, that is tan x. And cos x cancel. So this is plus 1. And that is your right hand side. So you see, this is how you will do the question number 5. It's E part. This is how you will prove that the left hand side is equals to the right hand side. So my dear students, now we will work on the question number 5 and its F part. Let me show you the question. So here you have question number 5 and its F part. It says 1 minus sine x minus 1 by tan x whole square is equal to 1 minus cos x 1 plus cos x. So we will try to prove that the left hand side and the right hand side, they are equals to each other. This is exercise 5G and this is our second episode on this exercise. So let's consider the left hand side. The left hand side. Okay. So the left hand side is 1 divided by the sine of the x minus 1 divided by the tan x, and then you have a whole square on it. You know the tan is how much? The tan can be replaced with the sine x by the cos x, and then you have the whole square. Bring this fraction upstairs. So this will become 1 by the sine of the x minus, when it becomes upstairs, it becomes cos x divided by the sine of the x, and then you have the whole square. And when you take the LCM will be sine of the x, and then you have here 1 minus cos of x, and then you have whole square on it. Okay. So so this is 1 minus cos of the x whole square and divided by the sine square of the x. You know the sine square x, it can be replaced. So you here have 1 minus cos of the x and whole square. In the place of the sine square x, I can write 1 minus cos square of x. Okay. So you know this 1 minus cos square x, these two are perfect squares. So it will become 1 minus cos x whole square, and this will become 1 plus cos of the x and 1 minus cos of the x. You see, these two are same. This is square, this is 1 power, they will be cancelled. So you are left with 1 minus cos of the x, and this thing 1 plus cos of the x, which is equals to the right hand side. So my dear students, this is how you will show question number 5 and F part is done. This is how in the F part of the question number 5 you will prove that the left hand side is equals to the right hand side. We are working on the exercise 5G. This is our second episode on this exercise. So my dear students, we are working on the question number 5. It's a G part, and this is the statement. We have to prove that the left hand side, right hand side, they are equals to each other. So let's consider the left hand side. So it says tan x plus 1 divided by the sine of the x, tan of the x plus cos x. Okay. So so very simple. I can write the sine x by the cos x plus 1. This is what happens in the numerator. And in the denominator, I can say sine of the x. In the place of the tan of x, I can write sine x by the cos x. And then you have plus cos of the x. Okay. So in the here you can see I can take the LCM. So you will have cos of the x. So this will become sine x plus cos of the x divided by, this will become sine square x. Sine square x divided by the cos of the x and plus cos of the x. Okay. So what we will do, we will take the sine of the x plus cos of the x divided by the cos of the x. This is in the numerator. In the denominator, I will take the LCM. So it will become cos of the x, and this will become sine square x, and this will become cos. So this will become cos square x. Okay. So you can write it like this: sine of the x plus cos of the x divided by the cos of the x. When you bring this upstairs, so this will become cos of the x divided by You know the sine square x plus cos square x. Let me write it once so you can understand what I am doing. So this becomes cos x and cos x cancelled. So you will have sine x into, sorry, the plus cos of the x, and this is cancelled. So sine square x plus cos square x, that is 1. So you can just say sine x plus cos of the x, and that is equals to the right hand side. So a little bit difficult, a little bit. So this is how you will do the question number 5 and its G part. I hope you understand this. So my dear students, now we are working on the question number 5 and its H part. First we have done the G part. I have not shown you the question, but now I'm working on the H part. Sine square x bracket 1 minus cos square x bracket close divided by cos square x bracket 1 minus sine square x bracket close equals to 10 raised to power 4x. Okay, so this is what we have to do. So our method is still the same. We have to prove that the left hand side is equals to the right hand side. So what I will do, I will consider the left hand side. So let's say consider your left hand side. Okay, so you have sine square x 1 minus cos square x divided by cos square x, and this is 1 minus sine square x. You remember 1 minus cos square x, first identity, 1 minus cos square x is equals to the sine square x. So here we can write sine square x, and you know the from the first identity, 1 minus sine square x, that is equals to the cos square x. So I can write here cos square x. 1 minus sine square x, that's equals to cos square x. 1 minus cos square x, that's equals to the sine square x. So sine square x multiplied with the sine square x, that becomes sine x, and the whole thing raised to power 4 divided by this becomes cos x raised to power 4. So you know this power is same, so you can say sine x by cos x, that is tan x and raised to power 4. And this is what we have to prove. And let me say this is your right hand side. So we have uh, my dear students, by this question we have completed the exercise 5G. It's question number 4 and 5 in this episode. This was our second episode on this exercise. We are working on the solution of the course book of the Pure Maths 1. This is the syllabus content of the paper 1 of the Cambridge International AS A-Levels Mathematics 9709. The topic of this chapter, chapter number 5 of this course book, is trigonometry, and the topic of this exercise 5G is trigonometric identities. This was our second episode on this exercise. My name is Farhan Mazhar, and that's it for this episode. I want to say thank you everyone who is preparing your AS mathematics from these videos. Please like this video, please share this video with those students who do not have too much help at their home. So these videos can be helpful for them. And you see, when you like my video, when you subscribe my channel, when you share the link of these videos on other social media platforms, this is an appreciation for my work, and this is an support for my work. Your appreciation, your support is very, very important for me. So thank you very much, everyone. Have a good night, sir. God bless you all.